Hi, and welcome to It's Not Obvious Java Edition, and today I will be talking about the for loop. Okay, so before you begin this episode, I highly recommend that you have already watched the Basic Loops episode because that's going to be a foundation that's going to help you understand this episode a lot more. Okay, specifically for today, I'm going to be covering the components of a for loop as well as the basic unary operands increment and decrement and the do's and don'ts of a for loop. This episode again is primarily intended for my CSS 142 students at the University of Washington, but it is also useful for anyone who is new to Java programming and wants to know how for loops work in Java. Right, so before we begin, I typically begin by answering the question, is this programming? Short answer is yes, a big part of programming is repeatability. That being said, my quick note here is to point out that we're still talking about tools and we're still talking about terminology for the most part. You are going to still have to figure out how to solve problems by yourself using your creativity and with the understanding of the tools that are available to you. Now, what I mean to say with that is that programming is not magic. You still need to figure out how to solve the problem first. If you are the kind of person who hopes that there's going to be some magical solution that are already available to you, unfortunately, you are not going to find it in this episode. And in general, that's not how programming works. All right, so let's talk about the basic components of a loop before we begin. As before, the basic components of a loop is what should happen before the loop begins. What should be the thing that triggers the loop that starts the loop in the first place? And what happens inside of the loop, inside of the body of the loop, and eventually the loop needs to stop because otherwise the loop keeps on going and you end up with endless loops, which is not a good thing. Okay, so let's think about the for loop. The for loop behaves very differently than the other loops that we've looked at so far. Previously, we looked at the while loop and we looked at the do while loop. The for loop is a little bit different. You want to think of the for loop as for X number of iterations, for some certain number of iterations that are predefined, do the body of the loop. And the number one thing that you should be thinking about is, why is this useful? What would you want to use this kind of loop for? Now, as it turns out, for loops are actually something that people use a lot in programming. But I have also taught long enough that I've seen people abuse how the for loop works. So I'm going to go over the do's and don'ts of what a for loop is. You might also notice that there's kind of this strange syntax where you have for in I equals 0, semicolon, I less than 10, semicolon, and then I plus plus. What do all of these mean? Now, you might be tempted to think that because you see a semicolon in here, you actually see 1, 2, 3 different statements. And you would be correct. Now, these are essentially their own statements. It's not quite the same as regular statements that we're used to, but effectively it behaves very, very similarly. For now, think of it as this is the syntax of what a for loop is. And then inside of the for loop, instead of this open and closing squiggly brackets, is the body of the loop that gets repeated over and over again. So let's talk about how things work in a for loop because it's not super obvious. The first thing that the computer does is it recognizes, oh, there's the keyword for, this is intended to be a for loop. And then you have this parentheses. And the first thing is actually a statement. This is a variable declaration. It declares the variable I, and it assigns the value 0 inside I. Now, this is what I call the initialization phase. This is the beginning of the loop. And then it executes the loop body. Before it executes the loop body, it goes into number 2, which is it checks the condition. We have in I equals 0. That's the starting point. Then it goes to number 2 here, and then it checks if I is less than 10. If I is less than 10, because right now it's 0, then great. It executes the body of the loop. So that's number 3. Perform every single step in the loop body, even if it's another for loop. In other words, you can have nested for loops. You can have nested a lot of things. Once the last line in the loop body is executed, once it reaches the last line and it reaches this closing squiggly bracket, it goes back up to number 4. It goes back up to what I call the update condition. And then after it updates the condition, it goes back into number 2. It checks to see what I is. at that point, and then it repeats as much as we want to, as much as we need to. Okay, so let's go into BlueJ and let's demonstrate what this looks like. As always, I begin with a demonstration of main hello world. We can run this to confirm that it works the way we expect it to. And then let's just begin with a simple for loop, kind of like what we have there on the slide. For in I equals 0, I less than 10, I plus plus. Okay, now inside here, inside of the loop body, you can do whatever we want. And let's say we do system out print line hello world. We can compile this, we can run this, and now we get hello world basically 10 times. Now, what's happening there? No, what's happening is that the computer goes in here and goes, I equals 0, 0 is less than 10, yes, that's true. It goes in here, it prints out hello world, and then it goes up to I++. I++ basically means take the value of I, increment it by 1. And that's probably a note that I want to include here. I++ is exactly the same as, as typing I equals I plus 1. Okay, so that's what I++ is. This plus plus thing is actually what's called a unary operator, whereas the regular operators, let's say the plus sign, requires two things, one to the left and one to the right, in order for the expression to be valid. The unary operators only need one thing, either to the left or to the right of it, for the operator to be valid. Now, there is actually a slight difference between I++ and ++I. For our purposes, it actually doesn't really matter. Later on, I'll talk about suffixes and prefixes for unary operators and how that changes things. But for now, it is essentially the same, and we typically, what you will commonly see is you'll see I++. All right, so let's talk about this a little bit more in terms of what's happening here. So first, we begin by creating this variable I inside of the for loop, which means that if you already have an I outside of the for loop, you're going to get the error saying that variable I is already defined in a method main. Now, same thing, if you go inside of the for loop and you say int I equals 0, it's also going to complain because it says variable I is already defined. So this is showing you that here in this statement, you really are declaring a new integer variable and you give it the name I, and that is available for this for loop. Now, another reason why you would see that this variable is only defined inside of the for loop is because if you try to create int I outside of the for loop, all of a sudden that's okay. Remember that this has to do with scope, and scope basically means that something exists inside of the block statement that it's in. In this case, int I only exists for the for loop. Outside of the for loop, it's gone, so which is why we can create another int I. All right, so that's one thing. Another thing is to keep in mind that int I can be anything that you want. So let's say if we begin by int I equals 0, and then I less than 0, we compile this, and if we try to run this, nothing happens because from the very beginning, int I equals 0, equals to 10. 10 is not less than 10. This is false, so the loop never begins in the first place. Okay, now another thing that you can think of is that inside of the body of the loop, similar to in the previous loops for the while loop and the do while loop, you can change the value of I. So now if we were to do that, it prints out hello world only once, because what happens is you begin with int I equals 0. You go in here and the first thing you do is you change the value of I to 10. You print hello world. It goes back up here to the I++. In other words, I equals I plus 1. So now I is 11. 11 is not less than 10, so it never repeats the loop again. Okay, so one last thing that I want to show you is that you don't necessarily have to declare int I instead of the for loop. You could declare int I equals 0, or you could actually declare int I equals 100, and then you can begin int I equals, so you can begin by saying I equals to 0, and this will compile, and this will run just fine, because even though the value of I is initially 100, when you execute this line, you get I equals 10, and in fact, if you were to print I after the loop, compile this and print this, you will get that the value of I is 10 because I starts from 0, increments all the way up until 10. 10 is not less than 10. It exits the loop, and now it prints I is 10. Okay, so this ties into everything that you've learned up until now, with how variables work, with how block statements work, with how scope works, with how if statement works, printing, everything. Everything builds up to this. Everything builds up until now. All right, so another weird thing for you to think about is that theoretically, you don't have to say I equals to 0. This is just a statement, and this is just an initialization. The computer looks at this first, executes this first, and even if you were to just say I, well, actually, in this case, it doesn't like it. It says not a statement. Let's say I equals to 1 or 1 plus 2. You can totally do this. And because this is now a statement, it will actually execute just fine, except that you begin with I equals to 3. Another weird thing is that you don't even need to have I in here in the first place. Let's say you have int y equals 0. You compile this, and you run this. And now what happens is you get I equals 100, y equals to 0. I is not less than 10, so it never executes. But say if we were to change int I out here to 0, okay, you get y equals to 0, I is less than 10, print the statement, increment I, and so the entire time y is just not used at all because this is just a statement. It can be anything you want. In fact, to show you one other thing that's a little bit weird, system out print line begin for loop. Now, remember that this is a statement by itself. And the way the computer works is that the computer just expects some sort of a statement, and you begin by executing this first. Then it checks if I is less than 10, which it is right now. It prints hello world, it increments I. All right, so there's a lot of weirdness here, and there's a lot of things that we really don't want to do. But I want to show you that these are things that can absolutely happen depending on how you implement the for loop. And depending on how you implement the for loop, it can radically change how things work. Now, I also mentioned earlier that this is another statement, and this is a conditional expression, and you can also, just like anything, you can change this to whatever you want. Okay, so first, let's get rid of that. And now we can do a conditional expression that says, let's say if we have int y equals 0, and if we have y greater than or equals to 0, and then we have I++ over here, well, what's going to happen is that it's going to execute I equals to 0, and then it's going to check if y is greater than or equals to 0, which it is, and then it's going to print, and then it's going to increment I a whole bunch of times. And just to demonstrate to you that this is using I properly, I'm going to print I plus hello world, compile, run this, and you'll see that I keeps on incrementing, and we keep on printing hello world over and over again, but it never stops because the condition is checking for y instead of checking for I. As you can imagine, this is essentially an endless loop. it just keeps on going for a while until it runs out of memory and we get the Stack Overflow error, or if we stop it, force the reset. Okay, so as you can probably imagine, not a great idea to use the conditional expression as something that we use other than the index that we initially want to use. Okay, less than 10. And the last thing that I want to demonstrate is this I++. And let's say that if instead of I++, we do Y++ over here, same thing, we execute this, and essentially, I is never incremented. I continues to be 0, and it just keeps on printing 0, hello world over and over again, because I never change inside of this for loop, because what gets updated is this Y value. It goes from Y0 and then Y++. In fact, let's demonstrate that so that you can see. System out print line I plus hello world, and let's say system out print line Y is plus Y. Compile, run, etc., etc., etc. You get Y is blah. I'm just gonna stop this so you can see a little bit better. The value of I never changes, but the value of Y keeps on changing over time because the update condition is updating Y instead of I. All right, so now let's talk about the do's and don'ts for a for loop. And keep in mind that these are general recommendations that are not necessarily true for all instances of usage. What that means is basically that you as the programmer, you as the person who's using all of these tools to do what you want with it, you get to decide what the right thing to do is. And these are general recommendations that, for now at least, I would recommend that you follow. But later on, once you're more familiar and you want to use these tools in a very specific way that are outside of what I recommend, totally feel free to do that, as long as it makes sense to you, as long as it's the right tool that you're trying to use. All right, so some do's and don'ts. You should have a predictable start or ending point. The number of iterations should be predictable. In other words, if we start with I equals 0, I less than 10, I++, you know that it's going to go from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Once it gets to 10, it stops. So you know that this is going to loop for 10 times. Number of iterations should be predictable. Okay. Now, it doesn't have to be super predictable. Let's say that instead of having a fixed number less than 10, let's say that we want to get a number from the user. So we'll use scanner, we'll import it again as always, and then we'll create an instance of a scanner equals new scanner system in system out print line, please give us a number. And then int num equals s.next int. Okay, so now instead of I is less than 10, we can be I is less than whatever number the user gives us. So we can compile this, and we can run this. Please give us a number, 3. We print only 3 hello world. If we run this again, and we give the number, let's say 20, we print 20 hello worlds. Now, it stops at 19.hello world because we begin with 0.hello world. So that's something that you might be thinking, well, I like the idea of using this. And I like the idea of using the for loop to count all the way from 0 to whatever. But do you have to begin with 0? What if you want to do 1.hello world, 2.hello world instead of beginning with 0.hello world? There's a couple of ways of doing this. And this is where the problem solving and the design comes in. One way of doing this is you can just do I plus 1 as an expression, compile, you can run this. And let's say we do 15. We begin from 1.hello world and you go all the way to 15.hello world. Another way of doing this is instead of modifying the print output, we can begin with 1 in the first place. So for int I equals 1, I less than num, I plus plus. All right, compile, run this, and let's say we do 3. The problem is it stops with 1, 2, because we need to see that I is less than num. Now, again, there's a couple of ways to do this. We can do I less than num plus 1, which is going to allow us to go all the way up until 3. 1, 2, 3. Or you can also do I less than or equals to num. Compile this, run this, and let's say we put 5. 1, 2, 3, 4, 5. All right, so again, this has to do with how you design your code and how you engineer the solution, how you solve the problem. Another thing actually that you can do that's a little bit interesting. Now, let's say you were to say that, hey, I like the idea of counting up from 1 all the way to 5. What if I want to count down from 10 all the way to 1? Well, you could actually begin with I equals to 10, and then you count down I is greater, let's say, than num, whatever the user gives to you, and then instead of I plus plus, you do I minus minus, and again, I minus minus is a unary operand. Read this as I equals I minus 1. And now all of a sudden, if we were to do that, and we go, please give us a number 5, we count down from 10, 9, 8, 6, 9, 8, 7, 6, and then it stops before we get to 5. Again, if you want to go all the way down to 5, you can do I greater than or equals to num. We compile this, and we run this, and we do 5. It counts down from 10 all the way up until 5, and then it stops. So again, there's a whole lot of things that you can do with a for loop. This is an idea on how you can use it. But again, you do want to have some predictable incremental update condition. For example, I++, or in the case I demonstrated just now, I minus minus. You should also define the index for just the for loop. Here we have int I, which is the index just for the for loop. You could define the index outside of the for loop, as I demonstrated earlier, but a lot of times that just leads to more confusion. So, which is why the recommendation is to define the index for just the for loop. Conditional expressions, in this case I, should really just be compared against the index, I greater than or equals to num, because again, earlier I demonstrated comparing the conditional expression to something other than the index, and that gets confusing real fast. Some of the don'ts, I've already demonstrated this. If you were to continually change the starting or ending point of the for loop, that could be a little bit chaotic. If you were to update the condition that are difficult or predict, that's also very difficult to follow and understand what the program's going to do. If you were to define the index outside of the for loop, again, I generally recommend against that at this point in time. Totally doable. It's completely up to you how you do that, but I generally recommend against that for now. And if the conditional expression is too complex or compared against more than the index, that can also be pretty chaotic depending on how you do it. Again, these are all just statements, and all the computer's expecting is that this is some sort of a statement, and this is some sort of another statement that becomes a Boolean expression, and this is just another statement, which means that if you really want, you can also say I equals s dot next int. For example, that could be a thing. And now this becomes extremely chaotic, and I'll demonstrate what that looks like in a moment. So, compile, run. Now, if I were to give a number, let's say 3, we do hello world, and then it asks us for another number again. And let's say I do 4, we get 4 hello world, and again, we're comparing I is greater than or equals to num. In this case, I is 4, as you can see. And let's say we go 5 hello world. I right now is 5, and num is the initial number that the user gave, which is a 3. Now, if we were to go down to 2, then it stops. If that example was confusing to you, that is intended to be confusing, and this is why I highly recommend that you follow the standard format of something like I++ or I-, even though you can do whatever you want for all of these different statements. This is the standard format. Once you are more comfortable with the for loop, and once you have a much better idea in terms of how you might want to use specific types of loops, feel free to explore and do whatever you want, but for now, the standard format is probably a little bit easier to follow. All right. So that's all for today. As always, I want to ask you, were there some things that were obvious to you, and were there anything new that you learned from this episode? If you like it, please subscribe for more content, because I'm going to be making more things like this. And if there were things that seemed obvious to me as I'm describing all of this, but it wasn't obvious to you, definitely let me know in the comments, and I will address it either in the comments or in future episodes. Thank you, and see you next time.